It has long been recognized that the law of Baer involving an erosion of the right side of rivers in the North Hemisphere by Coriolis acceleration, proposed in this paper, is false. This acceleration in the rotation of the Earth on itself is so small that it can in no way have such an effect. Moreover, the explanation given in this paper of the phenomenon meanders formation and of agglomeration of bodies denser than water rotating in the center of container rests first of all on an imperfect observation, but also on a total ignorance of the very principles of fluid mechanics. Science relies on the adequacy of quantitative results compared to measurements of observations. Mr. Albert Einstein did not propose any quantitative results, and the observation he referred to is not proven at all. I will not come back on Baer's law, which is fully rejected today. Here is the explanation offered by Mr. Albert Einstein. But near the wall of the cup, the liquid is held by friction, so that it circulates with a lower angular velocity than in other, more interior places. In particular, the angular velocity of circulation, and therefore the centrifugal force, will be lower near the bottom than at a higher height. This will result in a circulation of the liquid of the type shown in Figure I, which will increase until it has become stationary under the effect of friction on the bottom. The tea leaves are drawn by this circulation movement towards the middle of the cup. This explanation of the phenomenon of agglomeration of bodies denser than water in the center of container is based on an extremely summary and partly false observation. It is extended in the rest of the article to the formation of meanders. This is also the result of a total ignorance of the very principles of fluid mechanics. With the exception of the immediate vicinity of the walls of the container, the particles less dense than the fluid floating on the surface rotate with the fluid. The liquid rotates as a whole like a solid. It is obvious that if the container rotates at the same peripheral speed as the fluid, the movement continues indefinitely. The size of the container has no influence. Friction on the vertical walls of the container therefore plays no part. The height of the water in the container is also irrelevant. The dense particles gather in the center even if the height of water does not exceed their dimension. The particles less dense than the fluid floating on the surface and the traces of slightly greasy liquid which also remain on the surface, rotate with the fluid without being drawn towards the center or towards the periphery. There is no flow towards the periphery contrary to the figure of the paper. Accretion of particles denser than water at the center and bottom of the container does not occur when the container rotates at the same angular velocity as the water. Only the friction on the bottom of the container is therefore involved. The behavior of a perfect fluid in permanent flow in a container is governed by the Lagrange equation. A difference in level between two volume elements of a fluid in permanent flow cannot in any case generate a momentum, since it is exactly compensated by the weight of the column of liquid which separates the two volume elements. And what is true for a difference in level is also true for a difference in speed, and therefore for centrifugal acceleration, between two elements of volume of the fluid. This speed difference cannot generate any momentum since it is compensated by the pressure difference. There is always compensation between the terms of the equation because the sum is invariant. On the other hand, the friction on the bottom of the container generates a reduction in the speed of the fluid as it approaches the bottom. In laminar flow, friction is proportional to the fluid velocity. The liquid would therefore rotate as a whole per layer between two very close levels. This cannot result in any flow towards the center of the container, like in the whole of the fluid. But the Reynolds number in the water in the container is very high. The flow is therefore turbulent. Friction is proportional to the square of the speed. Liquid no longer rotates as a whole in liquid layers. There is therefore friction between the circular fluid threads. In the classic approach of friction, it induces pressure on the elements of a fluid threads parallel and in the opposite direction to the speed. This pressure cannot therefore generate any momentum perpendicular to the speed, contrary to what is stated in the paper. Most likely explanation of the phenomenon. Friction between fluid threads causes the fluid volume elements to rotate around themselves. The problem is that the complete Lagrange equation does not take angular moments into account. Friction generates differential velocities and therefore angular moments. Very small vortices with a vertical axis are thus formed in the zone affected by the friction. These vortices only concern a few millimeters above the bottom. They will tend to come together and merge with the vortex in the center of the container. These movements of concentration of the vortices carry the particles denser than water towards the center of the container. The vortex problem is explained in another video. This is a paradox of fluid mechanics, because the measured level of the free surface is higher than that given by theory. This paradox is waived by replacing the approach of friction by an analogy with solid volumes by an approach of friction between rotating fluid elements. Albert Einstein treated fluid mechanics as a sub-science. It concerns a basely material reality. It is obviously an experimental science, contrary to purely mathematical relativistic pure science. The problem today is that one wonders what pure science is actually about. Could time be a reality? It's stupid.